If you want to pass your technical interview, then you need to be able to pass the Roman to integer problem. Roman numerals are represented by 7 different symbols, and each symbol maps to a different value. For example, 2 is just written as II because it's 2 ones added together. 12 is written as XII, but is really just 10 plus 2. And the number 27 is written as XXVII, which is really just 20 plus 5 plus 2. This is where things get confusing. Converting numerals isn't as simple as adding them up. Sometimes you have to subtract, which they explain with these examples. That's a lot of information, but there's really only 2 things you need to understand about this problem. The first is that Roman numerals are just a mapping from a string to an integer, so we know we should be using a hash map for this. The second thing is that there's a simple set of rules about how to add them up. So if the number is smaller than the current number, then you add them together, and if the current numeral is less than the next numeral, then you subtract them. So XX is 10 plus 10, but IX is not 1 plus 10, it's negative 1 plus 10. So let's start by solving the problem with the simplest possible approach and the most common one. We create our map of numerals to numbers, and then the basic idea is to traverse the string from start to end, and for each character, we add its corresponding integer value from the Roman numeral map to a running total. If we call Roman to int XIII, the function will add 10 for x and then 1 3 times, resulting in a total of 13, which is the correct integer representation of the Roman numeral. However, what happens if we call Roman to int IV? The function will add 1 for I and 5 for v, giving a total of 6, which is incorrect, because like we just said, IV is 4, not 6. This is where our simplest solution fails, because if the current number is less than the next number, then we need to subtract instead of add. So let's do that in Python. We have to get the index of our items now so that we can get the current and the next numeral so we can compare them. If the current numeral is less than the next numeral, then we subtract it from the total, otherwise we add it. But there's a problem with this code. When we reach the end of a string, there will be no next item, so it will throw an index error, so we have to handle that case. With this updated approach, if we call Roman to int on xiv, the function will correctly return 14, 10 minus 1 plus 5. So this solution works and it works fast, but it's kind of ugly because of the repeated checks and indices. And because of that, it's a little more error prone when writing it in a high pressure interview situation. There's an even simpler way to write this using a weird trick, and I'm going to show you in a second. But first we need to talk about performance. The time complexity is how long it takes for our function to run as input size increases. Lower is better. In this case, the time complexity is O(n), where n is the length of the string. In other words, the solution is fast because it traverses the input string once. So the time it takes for the function to run increases linearly with the length of the numeral. Space complexity is how much extra memory we use to calculate the solution. We use a constant amount of space to store the map of Roman numerals to integers and the running total. So the space doesn't change no matter what the size of the input string is. That means the space complexity is O(1), in other words, constant. So performance-wise, our solution is highly efficient. It performs a single pass over the data and uses a minimal amount of space, meaning it can scale to really long numbers. But for an optimal solution, we still need to improve readability to make it easier to understand and less error-prone in the high-pressure environment of an interview. So what makes this solution hard to read? It's looking forward, because we need to compare with the next number. We can't get around that, but we can change the order of the input. All we have to do is reverse the string from the start. By doing this, we can keep track of the value of the last numeral we saw. If the current numeral is less than the last one, then we subtract its value. Otherwise, we add it. Now, this code does the exact same thing as the previous version, but is cleaner and easier to read. By iterating in reverse order, we avoid having to repeatedly check if we're at the last character, and we don't need to use indices to access the current and next characters. With this optimized approach, you're ready to handle any Roman numeral that comes your way. So what's next? First, you need to practice. I'll leave a link to this code in the description and a link to the Leetcode problem so you can try it. Then you should move on to the next problem in our interview list. Until then, this is Canonical Code.